Hi children, good morning all of you. Today we are going to study about unit number 1, the basic concept of chemistry and chemical calculation. So already see the previous class in the basic concept of chemistry, yes children. So what we saw in the topic, so in the topic is classification of matters, and then relative atomic mass and molecular mass. Okay, then atomic masses. So what is the relative atomic mass of hydrogen? Okay, what is the relative atomic mass of hydrogen? Yes, the answer is 1. So the hydrogen atomic mass is 1. Then oxygen, what is the relative atomic mass of oxygen? Yes, the oxygen relative atomic mass is 16. Okay, the atomic mass is 16. Then sodium, yes, sodium is 23. Okay, children. Then what is relative atomic mass? What is relative atomic mass? The relative atomic mass is defined as the ratio of the average atomic mass. Okay, ratio of the average atomic mass to the unified atomic mass unit. Okay, children. So now we are going to see about one new chapter. So in the topic is gastric acid and antacid. Okay. So in the gastric acid means இரைப்பையில் சுரக்கக்கூடிய ஒரு அமிலம். Okay. So in this acid is secreted in the stomach. Okay. The acid is secreted in the stomach. So that acid is called hydrochloric acid. Okay, that acid is hydrochloric acid. So in this hydrochloric acid is naturally segregated in the stomach. So you eat the food in the proper time. Okay, in the morning is 9 o'clock or 8 o'clock, and then afternoon is 12:30 or 1 o'clock. So in this you eat and food in the proper timing. So you eat the food of later time is 10 o'clock or 11 o'clock. The acid level is high. Okay, the acid level is high in your stomach. So the ulcer form when the acidity of high. Okay, so in the ulcer form when the acidity is high. So in this acidity, okay, high level of acidity is control the low level. So one of the tablet is antacid. Okay, one of the tablet is used in antacid tablet. Okay, so in this antacid tablet is used in the chemical name is aluminum hydroxide and magnesium hydroxide. So in this reaction, one of the acid base reaction. So in this acid is HCl, hydrochloric acid. So H plus ions present in acid, then OH minus ion, hydroxide ion is the acid. Okay, so in this HCl, hydrochloric acid, is react with aluminum hydroxide to give the form of aluminum chloride and water. So this is the acid base reaction. So in the next one reaction, HCl plus magnesium hydroxide to give the reaction is magnesium chloride and water. Okay, magnesium chloride and water. So this is one of the another one acid base reaction. So in this reaction, the mole concept. So that mole concept is the number of the substance. So the number of the compound. So in the first reaction, 3HCl. Okay, 3HCl. So in the number of the compound is 3. Okay, so the 3 moles of HCl. Okay, 3 moles of HCl and 1 mole of aluminum hydroxide, and then product 1 mole of aluminum chloride and 3 mole of water. Okay, then the second reaction, 2 mole of hydrogen chloride and 1 mole of magnesium hydroxide and 1 mole of magnesium chloride and 2 mole of water. So this is the mole concept of equations, mole concept of the equations. Okay children, then in the tablet ratio, okay, in the tablet value in the aluminum hydroxide and magnesium hydroxide, so one tablet above the composition will neutralized in 0.018 the mole of HCl, hydrochloric acid, for a person with the gastric acid content of 0.1 mole. Okay children, so this is the concept of gastric acid and antacid. Okay, gastric acid and antacid. So in the next one, Avogadro number. Okay, the next one is Avogadro number. So the Avogadro number is 6.022 into 10 to the power 23. So this is the Avogadro number. So the total number of entities present in 1 mole of any substance. Okay, the total number of entities present in 1 mole of any substance is equal to 6.022 into 10 to the power of 23. So he is the Avogadro is one of the scientists. So he is the Italian physicist. So this name is Amedeo Avogadro. Okay, Amedeo Avogadro. So he proposed one law. So that law is Avogadro law. So equal volume of all gases. Okay, equal volume of all gases under the same condition. That condition is temperature and pressure. Okay, that condition is temperature and pressure, that contains equal number of molecules. Okay, so this is the Avogadro law. The equal volume of all gases under the same condition, temperature and pressure, contains equal number of molecules. So in this Avogadro number is no unit. It does not have any unit. Okay, so only the Avogadro number is 6.022 into 10 to the power 23. Okay children, then one of the chemical equation. So the reaction 1 and reaction 2. So in this reaction 1, carbon is react with oxygen to give carbon dioxide. Okay, carbon is react with oxygen to give the reaction is carbon dioxide. So carbon C, oxygen O2, carbon dioxide CO2. So in the mole concept, okay, first you write the mole concept. So in this reaction only one carbon is present. Yes, so the carbon value is 1. So 1 mole of carbon. Okay, so in the first reaction is carbon react with 1 carbon is react with 1 oxygen to give the product is 1 carbon dioxide. Okay, then the next reaction is 1 methane. So the methane formula is CH4. Okay, methane formula is CH4. So 1 methane is react with 2 oxygen. Okay, 1 methane is react with 2 oxygen to give the product is carbon dioxide and 2 water. Okay, carbon dioxide and 2 water. So in the next one, the mole concept. Okay, next one in the mole concept. So in the mole concept means, so 1 carbon is react with 1 oxygen. So in the mole concept is 1 mole of carbon is react with 1 mole of oxygen to give the product is 1 mole of carbon dioxide. And in the second reaction, 1 mole of methane. Okay, 1 methane is react with 2 oxygen. So 1 mole of methane is react with 2 mole of oxygen to give the product is 1 carbon dioxide and 2 water. So 1 mole of carbon dioxide and 2 mole of water. Okay children, so this is the Avogadro number, and then Avogadro is the mole use the mole concept. So in the next one, molar mass. So in the molar mass is defined as the mass of 1 mole of substance. Okay, mass of the 1 mole of substance. So in the substance is atom or the element is the hydrogen and oxygen, sodium is the 1 mole of the substance. Okay, 1 mole of the substance is the atomic mass. Okay, so the molecular mass is defined as the mass of 1 mole of a substance. Okay, so in the molar mass of a compound is equal to sum of the relative atomic mass. So in the unit is gram mole minus 1. Okay, in the molar mass unit, okay, the molar mass unit is gram mole minus 1. So in the example, is 1 hydrogen. So in the 1 hydrogen, relative atomic mass unit is 1 U. Okay, So in the one hydrogen, so already see the relative atomic mass. Yes, so all of you studied. Yes, so in the one hydrogen relative atomic mass is 1 U. So in the molar mass of hydrogen atom is 1 gram mole minus 1. Okay, so the unit only change. Okay, unit only change. So in the relative atomic mass of one hydrogen is 1 U. Then molar mass of hydrogen atom is 1 gram mole minus 1. So in the next example, glucose. So what is the glucose formula? The glucose formula is C6H12O6. Okay, the glucose formula is C6H12O6. So in the relative molecular mass, so presence of carbon is 6. So in the carbon atomic mass is 12. So 6 into 12. Okay, carbon atomic mass is 12. So wait. Yes, the glucose. So the glucose formula is C6H12O6. So in the relative, calculate the relative molecular mass. So carbon atomic mass is 12. Then hydrogen atomic mass is 1. Then oxygen atomic mass is 16. Okay, oxygen atomic mass is 16. Then, so in this reaction, calculate the relative molecular mass. So the carbon 6 into 12. Then hydrogen 1 into 12. Then oxygen 6 into 16. Okay, 6 into 16. So the total value is 180. Okay, 180 U. So this is the relative molecular mass of glucose. Okay, this is the relative molecular mass of glucose. Then the next one, the molar mass of glucose. So the molar mass of glucose is 180 gram mole minus 1. Okay, the molar mass of glucose is 180 gram mole minus 1. Then the molar volume. Okay, then the molar volume. So in the molar volume, is the definition is 1 mole of any substance in the gaseous state. Okay, 1 mole of any substance in the gaseous state at a given temperature and pressure is called molar volume. Okay, molar volume. So in the next topic is gram equivalent concept. So in this gram equivalent concept is used in the analytical chemistry. Okay, analytical chemistry. So in the equal mass, okay, in the equal, you study the equal mass of the substance. So in the definition, so in the gram equivalent mass is defined as the mass of a element. Okay, mass of a element that combines the displace the atom. Okay, displaces the element. That element is hydrogen, oxygen and chlorine. So hydrogen value is 1 and oxygen the value is 8 and 8 gram and chlorine 35.5 gram. Okay, so one of the equation, zinc. Okay, zinc is react with sulfuric acid. Okay, zinc is react with sulfuric acid to give the product is zinc sulfate. Okay, zinc sulfate plus hydrogen. So in this hydrogen is displaced. Okay, in the H2, okay, in this hydrogen is displaced. So 1 mole of zinc value. Okay, so in the given values, okay, in the given values, 1 mole of zinc is 65.38 gram. Then displaces of hydrogen atom value is 2. So 2 hydrogens to 1 hydrogen, the atomic mass is 1. So 2 hydrogens, the value is 2. Okay, then the mass of this zinc required to the displacement of hydrogen. So calculate the value. So 65.38 divided by 2.016 into 1. So the value is, the equivalent mass of zinc value is 32.69. Okay, 32.69. So in the gram equivalent mass, so the equivalent mass of zinc value is 32.69. Then the gram equivalent mass of zinc is 32.69 gram equivalent minus 1. Okay, gram equivalent minus 1. So this is the concept of gram equivalent mass. So one of the formula of gram equivalent mass. So in the gram equivalent mass is equal to molar mass. Okay, molar mass gram mole minus 1. This is the unit. Then divided by equivalence factor of EQ mole minus 1. Okay, so this is the gram equivalent mass formula. So in this equivalent mass formula is used in the calculation. So acid, base and salt in the oxidation and reduction reagent calculation is used in the gram molecular equivalent mass. Okay, gram equivalent mass. So in the first one, acid. Okay, acid means the presence of hydrogen ion. Okay, acid means basicity in the presence of H plus ion, hydrogen ion. Okay, then base. Base is the presence of OH minus ion. OH minus ion. So one of the acid example is hydrochloric acid and sulfuric acid and nitric acid. Then the base example is sodium hydroxide and potassium hydroxide. Okay, then ammonium hydroxide. So this is the base. So in this acid, in the formula of equivalent mass, okay, equivalent mass is E. Okay, equivalent mass is E. E is equal to molar mass of the acid divided by basicity of acid. So all the chemical formula, okay, all the chemical formula you study must. Okay, all the chemical formula you study must and you study thoroughly. Then it is the useful for the calculations. Okay, children. So E is equal to molar mass of the acid divided by basicity of the acid. Okay. For example, the one of the acid is sulfuric acid. Okay, sulfuric acid H2SO4. Okay, H2SO4. So number of hydrogen 2. So 2 into 1. So that 1 is the hydrogen atomic mass. 1 is hydrogen atomic mass. Then sulfur. Number of sulfur is 1 sulfur. So 1 into 32. So the 32 is sulfur atomic mass. Already you studied in the table column. Yes, the element and atomic mass number table column. So you study compulsory. Okay. So next one, the oxygen. So the oxygen atomic mass is 16. So the total number of oxygen is 4. Okay, children. So the answer is 98 gram mole minus 1. Okay, 98 gram mole minus 1. Then 2 hydrogens are liberated. Okay, 2 hydrogens are replaced. Okay, 2 hydrogen is replaced. So 98 divided by 2. So the answer is 49 gram equivalent EQ minus 1. Okay, then the base. So in the base is presence of OH minus hydroxide ion group. Okay, so in the E is the equivalent mass. Okay, E is the equivalent mass. So in the equivalent mass is equal to molar mass of the base. Okay, molar mass of the base. So first one you see the acid reaction. Okay, first one see the acid calculation. So second one is the base calculation. So in the base then divided by acidity of the base. Okay, so one of the base example is KOH is the potassium hydroxide. Okay, KOH is the potassium hydroxide. So in the number of replacing hydroxide ion is 1 hydroxide. So KOH acidity is equal to 1 equivalent molar of minus 1. Okay, so the number of replacing OH group is only 1. Okay, so in the KOH potassium, so potassium atomic mass is 39. Okay, potassium atomic mass 39 and oxygen atomic mass 16 and hydrogen atomic mass 1. Okay, children. So potassium 1 into 39 and oxygen 1 into 16 and hydrogen 1 into 1. So the total value is 56 gram mole minus 1. So only one hydroxide ion is replaced. So 56 divided by 1. So the answer is 56 gram equivalent EQ minus 1. Then the next one is salt. The salt is the oxidizing agent and reducing agent. The presence of the electron, okay, that electron gain or loss, okay, loss of electron or gain of electrons, the number of moles of electrons, okay. So one of the salt example is sodium chloride and potassium permanganate and ammonium chloride, calcium chloride. These are the salt, okay children. So in the equivalent mass, okay, in the equivalent mass of formula, the salt, okay, so the molar mass of oxidizing or reducing agent, then the number of moles of electrons gain or loss of the 1 mole of oxidizing or reducing agent. So for example, in the salt is potassium permanganate, okay, potassium permanganate. So potassium K, manganese Mn and oxygen. So potassium atomic mass value is 39. Then manganese atomic mass is 55. Then oxygen 16. So total number of potassium is 1. So 1 into 39. So total number of manganese is 1. So 1 into 55. So the total number of oxygen is 4. So 4 into 16. Okay, 4 into 16. So the value is 158 gram mole minus 1. Okay children. So the 5 electrons, okay, removal of 5 electrons. So in this reaction, so in the replace the 5 electron. So number of electrons is 5 EQ mole minus 1. So in the 5 means number of replace the electrons, okay, 5 electrons. So in the gram equivalent mass of potassium permanganate is 158 divided by 5. So the answer is 31.6 gram EQ minus 1. Okay, this is the gram equivalent concept. Okay, this is the gram equivalent concept of gram equivalent mass calculation of acid, base and salt. Okay, acid, base and salt. The next topic is empirical formula and molecular formula. Okay, so first one, what is empirical formula? So in this empirical formula is the simplest formula of a compound is giving simplest whole number ratio. Okay, whole number ratio of atoms present in one molecule. Okay, present in one molecule. So in the empirical formula is the simplest formula of a compound. That compound means carbon, hydrogen, oxygen. So in the is present in the one compound. For example, glucose. Okay, glucose. So already you know the glucose formula. Yes children, that glucose formula is C6H12O6. Okay, so in the compound, the carbon, hydrogen and oxygen. So in the giving simplest whole number, so the whole number ratio is glucose C6H12O6. That ratio is 6 is to 12 is to 6. Okay, 6 is to 12 is to 6. So this is the whole number ratio of atoms present in one molecule. Okay, for example, CH. So carbon, hydrogen, oxygen in the presence of all compound is called organic compounds. Okay, is the organic compound. So for example, CH. CH is the empirical formula. Okay, CH is the empirical formula of benzene. So the benzene formula is C6H6. Okay, C6H6 is the benzene formula. Okay, so in the CH is the empirical formula is C6H6. Okay, C6H6 is the benzene formula. Then another one of the example is acetic acid. Okay, another one of the example is acetic. So one of the example is tamarind. So in this tamarind, presence of compound is carbon, hydrogen, oxygen. So in the given value of compound percentage, okay, in the given value of compound percentage. So in the 100 percentage, okay, 100 percentage tamarind. So in the presence of carbon is 32 percentage and presence of hydrogen is 4 percentage and presence of oxygen is 64 percentage. So first you write the table column. So first write the element carbon, hydrogen and oxygen. Then the percentage carbon 32 percentage, hydrogen 4 percentage and oxygen 64 percentage. Then the molar mass. So that molar mass means carbon. Carbon molecular mass is 12. Atomic mass is 12. Then hydrogen atomic mass is 1. Then oxygen atomic mass is 16. So in the oxygen atomic mass is 16. Okay, oxygen atomic mass is 16. Then the relative number of moles. Okay, relative number of moles is percentage divided by molar mass. Okay, percentage divided by molar mass. So 32 divided by 12. The carbon relative number of moles is 2.6. Okay, then hydrogen 4 by 1. The answer is 4. Then oxygen 64 divided by 16. The answer is 4. Okay, children. Then the simple ratio. Okay, simple ratio. So in this simple ratio is the smallest number of relative number of moles. So in the relative number of moles, which one is the smallest number? Yes, carbon is the smallest number. So is all the carbon, hydrogen and oxygen is divided in the smallest number of ratio. So in the smallest number of ratio is 2.66. Okay, 2.66. So carbon, hydrogen and oxygen is divided by. So in the answer of relative number of moles is divided by simplest ratio. Okay, is the simplest ratio. So the answer is carbon 1, hydrogen 1.5 and oxygen 1.5. Okay, children. Then the fraction of whole number. Okay, so which number is multiplying the whole number? Yes, the 2. Okay, multiplying the 2, the presence of whole, the fraction of whole number. So 1 into 2. So the whole number is 2. Okay, the simplest ratio is 2. Then 1.5 into 2, the value is 3. Then 1.5 into 3, sorry, 1.5 into 2, the value is 3. So the empirical formula is C2H3 and O3. Okay, the empirical formula is C2H3O3. So this is the tamarind empirical formula. Okay, children. So in some questions, give the value of percentage in the compound. Okay, give the value, the percentage of the compound. You calculate first the molecular mass, first the atomic mass. First you calculate the atomic mass and then you find the value of relative number of moles and then finding the simplest ratio. That ratio is converted into whole number. That ratio is converted into whole number. So that the answer is, empirical formula is C2H3O3. This is the empirical formula. Okay, children. So in this reaction, the next one is the acetic acid. Okay, in the next example is the acetic acid. So acetic acid is give the percentage. The percentage is carbon 40 percentage and hydrogen 6.6 percentage and oxygen 53.4 percentage. So first you find the atomic mass. First you find the atomic mass. So carbon atomic mass is 12, hydrogen atomic mass is 1, oxygen atomic mass is 16. So the relative number of moles. So the percentage divided by atomic mass. So the value is given 3.6 and 6.6 and 3.3. So the simple ratio. So which one is the simple ratio number? So 3.3 is the simplest ratio number. So carbon, hydrogen and oxygen, that relative number of moles value is divided by simplest ratio. Okay, simplest ratio. So the answer is carbon 1, hydrogen 2 and oxygen 1. So in the empirical value is C1H2O. So CH2O. Okay, CH2O. This is the acetic acid. Okay, so what is the acetic acid? acetic acid formula is CH2O. Okay, CH2O. So in this acetic acid is the presence of vinegar. Okay, in this acetic acid is in the presence of vinegar. Okay, children. So in the next sum, one of the number calculation. So the whole number calculation. So in this whole number n, okay, whole number n is equal to, so in the whole number is equal to molar mass of the compound. Molar mass of the compound divided by calculated empirical formula mass. Okay, so substitute the formula on table column. Okay, so the calculation of molecular formula from empirical formula. Okay, so in the some substance is lactic acid, hydrogen peroxide and acetic acid. So in the acetic acid empirical formula is CH2O. Then hydrogen peroxide is the formula is HO. So the hydrogen peroxide is the formula is H2O2. So the empirical formula is HO. Then lactic acid is CH2O. Okay, so the lactic acid and acetic acid. Okay, lactic acid and acetic acid in the empirical formula is same, CH2O and CH2O. So the molar mass, okay, in the molar mass. So in this molar mass is 60 and 34. Hydrogen peroxide is 34 and lactic acid is 90. Okay, children. Then the empirical formula of mass. So in this empirical formula of mass means the carbon. Okay, in the carbon, hydrogen, oxygen level. So in the carbon the atomic mass is 12 and hydrogen atomic mass 1 and oxygen atomic mass 16. So calculate the total value. So 12 plus 2 plus 16. Okay, so the total value is 30. Okay, then hydrogen peroxide. So the 17, the value is hydrogen and oxygen. Hydrogen 1 atomic mass and oxygen 16 atomic mass. So 1 plus 16 is equal to 17. Okay, children. So this is the empirical formula of mass. Okay, then whole number. So the whole number is equal to molar mass. Okay, molar mass divided by empirical formula mass. Okay, children, the whole number is equal to molar mass divided by empirical formula mass. So the answer is 2. So in the 2 is multiply the empirical formula. In this 2, whole number 2 is multiply the empirical formula. So what is the acetic acid empirical formula? CH2O. So CH2O is multiply into 2. Okay, children. So the answer is C2H4O2. Okay, C2H4O2. So in the same problem of next, the hydrogen peroxide. So in the whole number is 2. So the multiply the whole empirical formula HO into 2. Okay, so the molecular formula is H2O2. H2O2. Okay, children. So today we are learn about Avogadro number and molar mass and gram equivalent mass. And one more topic is empirical formula and then molecular formula. Okay, children. And now your homework. So what is empirical formula and what is molecular formula? Okay, children. So first question, what is empirical formula? And second question is what is molecular formula? And then the two calculations, example number 1 and 2. Okay, example number 1, the tamarind percentage of empirical formula, and then the acetic acid present in the vinegar. So in the two example 1 and 2, so you finding the answer, you write the problem and you write the answer in your homework note. Okay, finding the empirical formula. Okay, children. Thank you.